How about the cutting angle between two functions? This is actually, I would say it's easy, but I know also a lot of my friends in class, they had a lot of trouble with it. And actually we learned it not only once, we learned it several times. Since, of course, I think when you see it the first time, you think, oh my god, that's complicated. But it is really not complicated. And the way to deal with it is, I think, just first learn it by heart. And maybe the next time you apply it, it will become more and more clear to you. It's really, I would say, it is not that complicated. There are so many things in math which are complicated. But this one, I would say, come on. I'm just going to explain you, and I will also explain it to you later in the clip. But first, you can have a look at this chart. I hope you can see it. There we go. So, you see we have a y-axis, we have an x-axis, right? We have a linear function, the black one, and we have a x2, we have a x1, we have a y2, we have a y1. And actually it doesn't really matter which 2 points you take from the linear function. So I took 2 points, you see, 1 point here. So maybe I take something to point. Here, can you see it? This is a point, and this is a point. And it doesn't really matter which points you take, since you divide anyway. So, and the proportion, of course, this is always true for linear functions, the proportion is always the same, the slope is always the same, so that will not change anything. But you need 2 points. So we have x2 together with y2, we have x1 together with y1, and so we say x2 minus x1, that's delta x, and y2 minus y1, that is delta y. And the way it works, I have it here. Here you can see this is m is the slope, and then you just say delta y divided by delta x. That is y2 minus y1. Can you see? Divided by x2 minus x1. This is how it works. Nothing more. This is the slope of a linear function. It's always the same, right? So it doesn't really matter which 2 points you take. You have to take 2 points, and of course, maybe you take some points which are nice. So not maybe some fractions or something, but take some points which look nice. And if you have practice, it will also be much easier for you to recognize those nice points. And then you just do the division, always delta y divided by delta x. Then you have the slope. And actually, in the next step already for the cutting angle, you need a calculator. So there's not much to understand, but this, I think this is quite important, that you understand that you have a linear function, and actually this maybe I can also add. This is called the slope triangle, this one. Yeah, but this is the slope triangle, and so this picture you should always keep in mind. When you have a linear function, right, keep this in mind, then you will understand how it works, and you will really understand it. And that's the advantage of learning things by heart. When you can understand it, then it is easier for you to memorize. Or when you do both, you learn by heart and you really understand it, then you're very fast in exams. You won't make any mistakes when you have a lot of practice additionally, and then it's no problem. So I would suggest just maybe learn it by heart if it's difficult to understand. If you understand it, of course it's very good. And I'm also going to show you the same thing again in the following, so maybe when you see it twice, it is easier to understand. So I really hope you can understand it with my explanation, and just have a look at the following clip. I'm going to show you how to calculate the cutting angle between 2 linear functions, and this may sound a little bit difficult, but it is not. So what is meant with cutting angles? So we have a coordinate system, we have 2 functions, and there's an angle, and we want to know what's the cutting angle. So we need an intersection point for a cutting angle. For this exercise, we assume that we have 2 intersecting functions. So we have f and g, and first of all, assumption. Otherwise, this wouldn't make any sense. When the 2 linear functions are parallel, then of course I cannot
calculate any intersection or any cutting value, any cutting angle, because there's no intersection. So assumption f and g have an intersection. So, and I just write down the example. I'm going to explain it later how it works. So f is minus 8x plus 10. G is minus 5x minus 3. And first of all, we need to remember the basics of linear functions. So what we need, there's something which is called the slope. And the slope usually I call m. The slope you can see in a general linear function that is like this. This is a general linear function. That means that all linear functions can be expressed by this kind of definition. M is always the slope, then we have an x with the power of 1. That's how linear functions are defined. And we have some c without an x, and the c is the y-axis intersection, which you can see in this little picture. This is the y-axis intersection of the function of this function, but this is the y-axis intersection of the other function. So this you can directly read from the function. So we see f, the y-axis intersection is 10. Y-axis intersection of g is minus 3. And also the slope, which is m, you can read directly from the function here, minus 8 and minus 5. So it's not too difficult actually, but maybe you have to, of course you have to remember what the slope is. What is m? The slope is the degree, like for example, how to say, when you have when you're walking up some mountain, and of course then you can say, okay, when you walk up this mountain it may be very difficult. If you walk up this mountain it may be not very difficult. So the slope of this mountain is a lot bigger in terms of maybe the amount of the slope is a lot bigger than the amount of this slope. And also I can say the amount of this slope, now it's going down, is a lot higher than the amount of this slope. When we talk about amount, we just mean without the sign, because this slope in a coordinate system would be negative, this slope would be positive, but when we want to talk about the sort, if it's very steep, like this or this, then we can talk about the amount. But what does it really mean in a coordinate system? So we have a function, which I usually call f, and we can now draw a slope triangle. How does it work? This is a slope triangle. In this section we call delta y, this section we call delta x, this point we call x2, this point we call, or this x value we call x1, and the same we call this y1 and this y2. And now the definition of the slope, this is the delta x, the definition of the slope m is delta y divided by delta x, and this delta just means difference, and why difference? Because we take the difference of those two values, y2 minus y1 divided by x2 minus x1. This is the definition of the slope. So it means how much change do we have on one change of x. And this, what I just said, we obtain by dividing the y difference by the x difference. And knowing what slope is, we can go ahead and calculate now the cutting angle, or first of all the slope angle, which is defined the following. We have, the slope can be defined like m as tangent alpha. And this is the slope angle, this is the slope. And now we say tangent inverse, and we end up with the angle is inverse tangent of M. Now, last information we need how to calculate the cutting angle. And the cutting angle I call better is alpha f of one function minus the slope angle of the other function, and it's important that the first angle is bigger than the second. And this is how the cutting angle is defined. And then I would say we have enough theory. So you see this part on the right is the theory part. And it's important, I think, that you understand it completely. Especially the slope here with the slope triangle. This is an important thing to know. Then you know how the slope is defined of a linear function. When you know the slope, then you can calculate the slope angle. When you have two slope angles, you can calculate the cutting angle, of course under the assumption that both functions have one intersection point. So we know the theory, and now let's just calculate it actually. So we know both m's, we can write it as the slope of f we know is minus 8. We can just copy the value in front of the x. Then we have the slope. And same thing with g, we know minus 5, we see it. Then we can calculate, since I said we calculate the slope angle, like with the inverse tangent. So we say alpha f is inverse tangent of minus 8, which is, we don't know yet, we need a calculator. And same thing for g. Alpha g is inverse tangent of minus 5 is, we also don't know it, because we need this machine to calculate it. So we take shift and then tangents to get the inverse tangent of minus 8. And now one thing, I get a lot of comments on YouTube, and this is actually how it doesn't work, but I want to show you. Now you press enter and you think, okay, my angle is minus 1.4 something degrees, but this is wrong, because maybe you forgot some very important thing. In this case, there's a problem because this is not degrees. This is actually, how to say, this is a different measure which I don't want to treat here. But when you talk about geometric, you always have to use degree about geometric angles. So in this case, we have to press mode. We have to change the mode, and there we are. We have degree, radian, and this is what we actually don't want to have. But the calculator accidentally, of course, is set to radian, but we want to have some geometric angle. So we should take 1 degree. Then we know how much degrees the angle is. So again, we have to calculate it. Shift tangent of, what did we say, minus 8. Or maybe with brackets, minus 8. And then we end up this as in degrees. And you can also note it, but you don't see it probably, this is a D for degree, and before there was a R for radian. So you should definitely, if you calculate geometric angles with a calculator, you always have to check. Are you in degree mode or are you in radian mode? Always check. Or you have to make sure that you know what you're calculating. So minus 82.87 degrees. Now we do the same thing for G for minus 5, and we see minus 78.69 degrees. And I just forgot, I should actually save the values. So this I save in B, and the other value, minus 8, I will save in A. And then we need to go to the last step, which is here we calculate the cutting angle. Of course, we already assumed that F and G have an intersection, so we can calculate it right away. If you're not sure then you can just calculate whether there's an intersection or not. Maybe I can do it later just to show you. Maybe it makes it more clear. So in this case we want to calculate the cutting angle, which is we take the bigger value minus the smaller value. In this case both is negative, but this is absolutely seen, this is bigger. So we say minus 78.69 degrees minus 82.87 degrees, and we end up with, so we say B minus A, we end up with 4.18 degrees. So this is the cutting angle. Not too difficult, and if you are still not sure, you can have a look. You can pause the video and have a look at the theory part, or you can repeat it. This should be absolutely clear, the theory part, and then you can just calculate it. But maybe as last step I just want to show you that there is really an intersection point. Usually you should, if you're not sure or if it's not given in the exercise, you should check whether there's an intersection point or whether both functions are parallel, or whether it could also be that both functions are actually the same. Then of course you cannot really calculate a cutting angle, or it would be 0. Then we just do it. We have minus 8x plus 10 equals minus 5x minus 3. So we say plus 8x plus 3. So we end up with 13 is plus 3x. Then we divide by 3, and then we end up with something which does not really look so nice. Calculator, 13 divided by 3, and we end up with 13/3 is x. So there is a intersection. Usually you should calculate this first. If it's given in the exercise that both functions have one intersection point, you can assume this, then you can calculate the intersection, the cutting angle right away, and you can do this with the theory part, like with a tangent, inverse tangent, and then cutting angle by a subtraction of both angles, bigger one minus the small one. So this is how it works. Not too difficult, but of course practice makes perfect. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.